Zone 5 is the hydrosphere, the ocean waters which covers most of the Earth's crust. Zone 6 is the atmosphere, which is the air. It goes from the surface of the continents and the surface of the ocean waters all the way up to about 100 miles into space. Now let's go back to the mantle and crust, zones 3 and 4. Because these are the area of mineral deposits and exploration, geologists have divided these two zones somewhat differently into what we call the Asthenosphere and the lithosphere. Let's look at the differences. Geologists made their divisions based on the material strength of the layers, how they behave, not on their composition like in the other zones. The Earth's outer shell is a strong layer made up of the harder mantle and the crust, about 100 to 200 kilometers thick, and is called the lithosphere. It overlies a weaker layer called the Asthenosphere, made up of the softer mantle. As I said, the lithosphere shell is made up of the harder mantle and the crust, which we can further divide into oceanic crust under the ocean or continental crust on the land. The lithosphere shell is not a continuous layer. It is formed from a number of fragments or plates that crisscross the Earth's surface. Its upper part, called Tectonic Plates, are strong and move over the weaker, softer Asthenosphere. These plates move in various directions, away from, toward, and sideways from each other, growing the mountains and digging the trenches. Today, satellite measurements have recorded plate movements from 2 to 10 centimeters per year. The lithosphere is of interest to humanity because this is where the minerals are that we need for our existence. The softer, weaker Asthenosphere is a plastic. We use the word plastic here to describe a rock that is not a solid nor a liquid and is under high pressure and temperature. The Earth is dynamic. The moon is static. What I mean to say here when I say the Earth is dynamic, I mean that it changes. As you know, the Earth is always changing. The plates and continents move. We have weather that can change from day to day, season to season, even from millennium to millennium. The opposite of dynamic is static. The moon is static. It does not change. There are no continents to move, weather to change, or particles to erode. It doesn't even change from day to night. Except for a meteor hitting it every so often, nothing on the moon changes. Whereas on the Earth, we have water that is moving. We've got weather that is changing. We have the water cycle where water is changing to vapor to liquid to ice. Wind and current that change and causing weathering and erosion. Even the continents are moving, creating and destroying mountains and forming trenches. The Earth is dynamic because things are always changing. All this movement shapes the Earth as we know it, but what forces are causing these changes? What forces cause the Earth to be dynamic? There are two basic forces that shape the Earth's surface: internal and external heat. Internal heat, which comes from within the Earth, moves the tectonic plates. There are two sources of internal heat. The first internal source is the heat left over from the huge amount of energy released during the formation of the Earth. The second comes from the radioactive decay of minerals present in the Earth. The unstable elements are called isotopes. They are atoms, they are unstable, and want to go from an isotope to a stable atom. When this occurs, they give off some gamma rays or particles, which are forms of energy that are released as heat. Where did this radioactive material come from? When the rocks were hot, 4.55 billion years ago, many of these isotopes were formed. Since they can have half-lives of 1 billion years or so, it means that they are still there, and little by little, one at a time, they are slowly going back to their natural state, creating heat, so there's a steady heat coming from the center of the Earth. This is a major source of Earth's internal heat. The external heat, the second source, is solar. The heat we get from the sun. Because of the rotation of the earth, this heat is not constant, but changes with the seasons and causes climate. We have winter, we have summer. The weather and the climate of the earth is always changing, creating temperature variations, creating weather. Weather causes weathering and erosion. It controls the water cycle, the wind cycle, the ocean currents. It also permits life. Without the solar energy, our planets and animals couldn't grow. So without the sun, we wouldn't have much life. We need this external heat. We depend on its seasons, its weathering, its erosions, its cycles to give us life. Weathering and erosion are interesting phenomena that take place on the earth. Called geologically destructive, weathering breaks down the earth with wind, water, and ice. And then erosion moves it to another place. From our sources of internal and external heat, the rocks on the dynamic earth also undergo change. This process is known as the rock cycle. Here's a model with our inner core, which is solid. The outer core is very liquid. Sometimes it gets so hot it heats the mantle and the crust, and it breaks out into volcanic chains, causing volcanoes, bringing some of the hot rock up to the surface, creating new crust. This also transfers a lot of heat to the surrounding Asthenosphere, creating a conductive heat current which pushes the plates above them in the lithosphere. In some places, new crust is being made, and in some places, old crust is being destroyed from the moving plates. This is part of the rock cycle. Sometimes new rock is being made, sometimes old rock is being destroyed. So the rocks, over millions of years, are always changing. In this rock cycle, there are three classifications of rocks: igneous, sedimentary, and metamorphic. Igneous rock is formed when liquid magma coming up out of the volcanoes cools into a solid. This rock creates new mountains. Once these mountains cool, the external heat drives the climate changes that cause weathering and erosion. That begins the breaking down and tearing down of the mountains. Wind, water, and ice break down the rock of the mountains and then move it away, eventually moving it towards and into the oceans. These particles are deposited in layers as sediment that over time turn into sedimentary rock. Finally, these sedimentary rocks get pushed down into deeper levels and under high pressure and high temperature are changed into metamorphic rock. Eventually, metamorphic rocks are pushed even deeper until they are melted and turned into magma, and the cycle starts again.